Hey everybody, let's look at this one from 1976. This is an oldie but a goodie here. It says the two guide rails for the elevator shown above each exert a constant friction force of 100 newtons. So each guide rail, 100 newtons. On the elevator car, when the elevator is moving upward with an acceleration of 2 meters per second squared, the pulley has negligible friction and mass, so no friction up here. Assume G equals 10 meters per second squared. So this is basically an Atwood machine problem. We got a mass on this side draped over a pulley, mass on this side here. First thing they want us to do is to draw a free body diagram for the elevator car there. So let's do that. So on here, we've got each one of those guardrails exert a friction force. Now you can draw them as one. I'm going to draw them as the force of friction on the right rail and the force of friction on the left rail there. And then we've also are going to have here the force of gravity on the elevator car itself. And then the last thing we have on it is the tension in the cable, so the force of tension acting up on it there. And since it's accelerating up, I know that this one has to be bigger than all of these combined. So next thing they ask us to do is to calculate the tension itself on the car. So to do this, we always start with Newton's second law. And so let's write it for the elevator car. The sum of forces on the elevator car is equal to the mass of the elevator car times its acceleration. So let's write all the forces we can think of on the elevator car. We've got tension up. We've got the force of friction on the left down. We got the force of the friction on the right guardrail down. You could, again, combine these into one idea. And we got the force of gravity down. All of this is the sum of the forces. So all of this will equal mass times acceleration here. Now, I'm going to move these all, since they're being subtracted here, I'm going to add them all over to this side, and I'm going to start to substitute in for their values. So we've got the tension is equal to the force of friction on the left one is 100 newtons. The force of friction on the right one is 100 newtons. The force of gravity, since it's a 400 kilogram elevator car, it will have a force of gravity of 4,000 newtons. And then finally, we got to have this term right here, mass times acceleration. So 400 kilograms times the upward acceleration of 2 meters per second squared. And that will give you 800. And so then 800 plus 4,000 plus 100 plus 100, and that will give us a total tension here of 5,000 newtons on the cable car. So now, next thing we've got to do is we've got to calculate the mass, capital M, of the counterweight. So if we go back and look at this picture here, we've got this elevator car here, but then we've got this lifting force is being supplied by this counterweight of mass M here, and that's what we're going to try and find. So let's actually draw it from the viewpoint of that counterweight here. So we've got this counterweight of mass, capital M, and what are the forces on it? Well, we've got the tension upwards on it, and we've got the force of gravity downwards on it. So if I take that and write that over here, the sum of the forces on that mass is going to equal that mass itself times the acceleration. And that mass, since it's part of the system that we mentioned before, it's going to have the same upwards acceleration of 2 meters per second squared. Although for it, the acceleration's down this way. So what are the forces? I'm going to call the way that it's moving the positive direction. So I'm going to say the force of gravity is positive minus tension back the other way there, like that. So I'm looking for the mass here. We know the tension as well. So let me actually move two things at once here. I'm going to move this, subtract it to the other side, and I'm going to substitute in for the force of gravity, because it's going to be mass times gravity is this, and then I'm going to subtract this over to this side here and add the tension on that side. So that is what we have now. Let me factor this mass out. So tension is equal to mass times the quantity of gravity minus acceleration. And so now we're almost there. We can see how we're going to get this mass. The mass is going to be equal to tension divided by the quantity of gravity minus acceleration, like that. And now we can simply plug in. We've got these values. We've already solved that the tension is 5,000 newtons. We know that gravity is 10 meters per second squared. We know that the acceleration is 2 meters per second squared. So you'll get 5,000 divided by 8, basically, and that will give you 625 kilograms.